In the modern world, we expect things to be available. We walk into a store, and the shelves are lined with products from every corner of the globe. A simple click online can summon almost any item directly to our doorstep within days, or even hours. This system of global trade and logistics operates with such quiet efficiency that most of the time we barely notice its existence. It is the invisible architecture of our daily lives, a complex network of ships, trucks, warehouses that ensures the continuous flow of goods. This reliability has become a fundamental assumption of the 21st century economy. Yet this perception is often challenged by a starkly different reality. News reports surface, speaking of critical shortages and production halts. Automakers pause assembly lines, waiting for a single missing component. Hospitals struggle to source basic medical supplies. Satellite images might show dozens of container ships anchored idly outside major ports, unable to unload their cargo. Warehouses, far from being empty, are sometimes filled to capacity with goods that have nowhere to go. This presents a strange and unsettling contradiction. The system appears to be failing in paradoxical ways. On one hand, consumers are told that products are unavailable due to supply chain disruptions. On the other hand, the physical evidence points to a massive logjam of goods stuck in transit or storage, while the factories that need them stand silent. How can a system designed for maximum efficiency simultaneously create such profound inefficiency? The headlines often provide simple answers, blaming isolated events or temporary crises for the disruption. But these explanations feel incomplete when faced with the sheer scale and persistence of the problem. The quiet tension between full shelves and idle ships invites us to look past the surface and understand the system itself. At its core, the global supply chain is a system designed to move physical goods from a point of origin to a point of consumption. Think of it as a vast, planetary-scale conveyor belt. This system is not a single entity. It's a network of interconnected processes and infrastructure. It begins with the extraction or cultivation of raw materials, transformed into intermediate components, transformed into finished products. The journey continues through a complex web of distribution centers, ports, and transportation networks, until the final product reaches a retailer's shelf or a customer's front door. This global network operates on four primary flows: products, information, money, regulations. One of the most important is lead time, the total time from the initial order to final delivery. Another critical metric is inventory turnover. It measures how quickly a company sells its stock. The system's success relies on every component operating in precise harmony, like the gears of a massive, intricate clock. When synchronization breaks down, the effects ripple through the entire network. The global supply chain is not an automated, self-running machine. It is a complex ecosystem of human actors and organizations, each playing a specific role. At the beginning of the chain are the producers and manufacturers. These are the entities that convert raw materials into finished goods. Manufacturer, shipper, port, customs, logistics, warehouse, retailer. This is the domain of shippers and logistics firms. They are the third-party firms that manage transportation, warehousing, and customs clearance. As goods approach their final destination, they pass through the hands of ports and regulators. Regulators, including customs agencies and government bodies, oversee this flow. They enforce trade laws, collect tariffs, and ensure that products meet safety and quality standards. Finally, at the end of the chain are the retailers and financiers. Retailers are the interface between the supply chain and the consumer. Financiers provide the capital that lubricates the entire system. Their willingness to extend credit and invest in infrastructure is essential for the system's continued operation and growth. When supply chains falter, one of the most frequently cited causes is a sudden and unexpected shift in demand. The global system is engineered for predictability. relying on historical data and forecasting models to anticipate how many products consumers will want to buy. During the early stages of a global health crisis, demand for personal protective equipment, cleaning supplies, and home office equipment skyrocketed almost overnight. Simultaneously, spending on travel, dining, and live entertainment plummeted. This was not a simple increase in overall consumption, but a massive, rapid reallocation of spending. The supply chains configured to produce airplane parts were suddenly idle, while those for webcams were overwhelmed. This phenomenon, known as the bullwhip effect, amplifies the initial demand signal at each step, creating wild swings and instability throughout the network. However, blaming demand spikes alone provides an incomplete picture. While these shocks are real and disruptive, they do not fully explain why the system remains unstable for months or even years afterward. The sudden shift in consumption acts as a stress test, revealing pre-existing fragilities that are otherwise invisible during periods of stability and predictable growth. Beyond the fluctuations of human behavior, the global supply chain is exposed to the raw and unpredictable power of the natural world. A major hurricane can shut down ports. A severe winter storm can ground air cargo fleets. An earthquake can physically destroy manufacturing facilities. These shocks highlight geographical vulnerabilities. Manufacturing has become highly concentrated in certain regions. If the majority of the world's supply of a specific electronic component comes from one disaster-prone area, the global system dependent on that component becomes fragile. The reason short events become long disruptions is the system's lack of slack or redundancy. The drive for efficiency has stripped away backup inventory, alternate suppliers, and excess capacity. The global supply chain is not just infrastructure. It is powered by people, truck drivers, warehouse staff, port operators. Another commonly blamed cause is a shortage of this essential labor. Not enough trained people to do critical roles and bottlenecks emerge. Goods may arrive at a port, but without enough crane operators and truck drivers, they go nowhere. A strike at a port can create a massive backlog. Demographic shifts and changing job preferences can cause chronic shortages. The work is demanding, and low pay and poor lifestyle fit make recruitment and retention hard. So the labor problem is a direct consequence of the system's economic structure. Beneath the surface causes of disruption lies a deeper, more fundamental driver, a relentless, decades-long pursuit of efficiency. The goal is to make the journey of a product as fast, direct, and inexpensive as possible. This intense pressure for cost reduction has created a system with very little slack. From a pure efficiency standpoint, all of these things look like waste. The ideal becomes a state of constant motion, where goods are never at rest, flowing seamlessly from one point to the next. The problem is that a system optimized solely for efficiency becomes inherently brittle. It performs exceptionally well under stable, predictable conditions. But when an unexpected shock occurs, it has no capacity to absorb the impact. It is like a finely tuned race car that sets records on a perfect track but breaks down at the first sign of a rough road. A key manifestation of the drive for efficiency is the widespread adoption of just-in-time. The principle is elegant in its simplicity. Materials and components should arrive at a factory at the precise moment they are needed for production. The success of just-in-time created a powerful feedback loop. As more companies adopted it, the entire logistics industry evolved to support it, creating the illusion of a perfectly synchronized global machine. However, the just-in-time model rests on a critical assumption that every link in the supply chain will function flawlessly. A single delayed shipment of one minor component can be enough to halt an entire assembly line for a multi-billion-dollar product. This inherent fragility was exposed when the system began to experience shocks. It immediately created shortages for just-in-time manufacturers thousands of miles away who had no buffer stock to rely on. These delays, combined with each company's attempt to manage its own uncertainty, create a powerful and destabilizing feedback loop, the bullwhip effect. Each actor is making rational decisions with limited information. They only see orders from their direct customer. They do not see true consumer demand. That causes a pendulum swing from shortage to surplus. Excess inventory floods the system, prices fall, and production is slashed. Another hidden driver of fragility is the global concentration of production. Many industries have consolidated their manufacturing and sourcing in a small number of specific geographic regions. This leads to the creation of massive industrial clusters that dominate the global supply of a particular component. Semiconductors in East Asia, active pharmaceutical ingredients in specific parts of China and India. The danger of this model is that it creates massive single points of failure. The entire world becomes vulnerable to a local disruption. The system has no easy alternative. The choices that make supply chains fragile are driven by powerful financial incentives. Strategies that boost short-term efficiency are often rewarded by the market. This dynamic is compounded by the practice of outsourcing risk. Large corporations can use their market power to push risk down onto smaller suppliers. The risk hasn't been eliminated, it's just moved to a weaker part of the chain. The hidden drivers interact and reinforce one another. That creates a system where small, localized shocks get amplified into major crises. A 2-week fire becomes a 6-month global shortage. The initial shock was small, but every stage amplified it. They combine into a perfect storm of fragility. When the finely tuned global supply chain system begins to falter, one of the most immediate and widely felt consequences is economic, setting in motion a cascade of cost increases. This forces them to raise their freight rates. Manufacturers facing shortages pay a significant premium, passing them on to the next buyer. The impact ultimately reaches the consumer in the form of higher prices for everyday goods. It is a direct tax on fragility, paid by everyone. The automotive industry, for example, has been forced to repeatedly pause assembly lines, not because of a lack of demand for cars, but because of a persistent inability to source all the necessary electronic components. This has direct consequences for employment, investment, and economic growth, demonstrating that the health of the supply chain is a fundamental pillar of modern economic stability and prosperity. The systemic failures reshape the physical and geopolitical landscape, prompting companies to seek alternate, less congested routes. In response, businesses and governments explore nearshoring and reshoring, bringing manufacturing back to a company's home country, prioritizing supply security over lowest cost. Nations start to view control over critical supply chains as national security. Semiconductors, medical supplies, rare earth minerals. This can lead to new protectionism. The cooperative spirit of global trade can be strained by a zero-sum mindset. The effects of these disruptions are profoundly unequal. Smaller businesses are disproportionately harmed by the instability. When we examine the full picture, the persistent failures of the global supply chain are not the result of any single cause. They are the predictable outcome of the system's fundamental design. This singular focus created a fragile global web, a structure that performs with remarkable precision in a stable world, but is destined to fracture under pressure. The result is the paradox we see today, a system capable of incredible technological feats that is simultaneously brought to its knees by the smallest of frictions. The empty shelves and idle ships are not a sign that the system is broken. They are a sign that the system is revealing its true nature. The efficiency we enjoyed for decades was not free. It was paid for by taking on a hidden, systemic risk that has now come due. This leads to the central, unresolved tension that will define the future of global trade. This would mean intentionally reintroducing the waste that was so carefully eliminated, choosing security of supply over the lowest possible price. A resilient supply chain is an expensive supply chain. Products that have become cheaper over decades would see their prices rise. This raises the ultimate question: who should pay for this resilience? Should individual companies, or should governments intervene? The global system is therefore caught between the known expense of building resilience and the uncertain, potentially catastrophic cost of continued fragility. You've been watching System Atlas, exploring how the world's systems really work.